Okay, we're asked to differentiate y equals the square root of x using the definition of a derivative. Now, the definition of a derivative is for any function y is equal to a function of x. The definition of the derivative of the function, or f prime of x, is going to be equal to the limit as h approaches 0 of the function at x plus h minus the function at h, all divided by h. So what we're going to have to do is we're going to have to substitute this function into this algorithm and then try and algebraically simplify it, or simplify it using algebra. So let's start. So this is going to be equal to, if we input the square root of x, the limit as h approaches 0 of the square root of x plus h minus the square root of x, all divided by h. Now, that doesn't really help us at the moment because we can't combine any of the terms on the numerator of this fraction. So what we're going to do is I'm going to rationalize this numerator. So the way I'm going to do that is I'm going to multiply it by essentially 1, but I'm going to write it in such a way where, so this is going to be x plus h square rooted plus the square root of x all divided by square root of h, x plus h, plus square root of x. Now, what I've done here is I've taken advantage of what's called the difference of perfect squares. And what this says is if we have like x minus a, x plus a multiplied together, this is going to equal x squared minus a squared. So if we apply this to this, the numerator multiplication, what we're going to have is it's going to be, if we're calling x the front term, this is going to be x plus h all squared, which is going to just be x plus h, so it's going to be the limit as h approaches 0 of just x plus h minus square root of x all squared, which is just x all divided by h times square root of x plus h plus square root of x. Cool. So what I've essentially done is I've just multiplied those two fractions together. Now what we're going to be able to do, the reason we did this is so at the top I can now collect my like terms. I have x minus x, so they're going to cancel each other out, and I'm just going to be left with h on the top. Now what's going to happen is this h here is then going to cancel out with the h that I have in front of the bracket down here. So I'm just left with 1 up the top. So I can now rewrite this as the limit as h approaches 0 of 1 divided by square root of x plus h plus the square root of x Now what we can do is we can then take the limit as h approaches 0. So I usually, when I'm taking the limit, I'll just write it as a statement. So I'll just write as h tends towards 0, comma, the denominator, which I'm going to have to write, square root of x plus h plus x, square root of x, tends towards, well, if the h approaches 0, this is just going to tend towards 2 square root x. Because it's just going to be square root of x plus square root of x is 2 square root of x. And then what you can do is, because that's what it's going to approach, once we've taken that limit, we can then write, therefore, f dash of x is equal to 1 divided by 2 square root x.